Hello, everyone. In our last class, we learned about the detection principles, structural classifications, and development trends of coordinate measuring machines, CMM. As precision inspection equipment, CMM plays a crucial role in industrial production. However, its accuracy and reliability depend not only on the performance of the equipment itself, but also on the professional competence and responsibility of the operator. Today, we will use Hexagon's coordinate measuring machine as an example to learn about the basic operation of CMM, focusing on the startup and shutdown operation specifications and measurement process. We will also emphasize the importance of responsibility during the operation process. Through this class, we hope that you will master every step, from preparation before startup to wrapping up after shutdown, ensuring that the operation follows specifications and preventing equipment damage or measurement errors. Now, let's look at the first part: startup and shutdown operation specifications. Pre-startup preparation. Inspect the machine's appearance and check for any obstacles on the machine guide rails. Clean the guide rails and flat surfaces. Check if the temperature, humidity, air pressure, and power supply meet the required standards. These seemingly simple steps are actually crucial for the long-term stable operation of the equipment and the accuracy of measurement results. As operators, it is our responsibility to ensure these preparations are strictly carried out. Next, let's go over the startup operation process. Step 1. Turn on the air source. The air pressure should be above 0.5 MPa. Step 2. Power on the control cabinet and the computer. Step 3. After the system completes self-checking, press the machine start button on the control handle to power up the system. Step 4. Right-click to open the PCDMIS software with administrator privileges. Follow the prompts to return the measuring machine's probe to the 0 position. Step 5. Select the unconnected probe. Create a new measurement program to enter the working interface. Each step must be carried out carefully and precisely, as any oversight could lead to equipment malfunction or measurement errors, ultimately affecting product quality and production efficiency. Now, let's look at the shutdown operations. After completing the measurement of the workpiece, the probe should be moved to a safe position and height, with the probe facing inward to prevent accidental collisions. Then, exit the PCDMIS software and turn off the control cabinet power, the computer, and the air source. During the shutdown process, we must not only follow the strict steps, but also maintain a sense of responsibility for the equipment and our work. Every correct shutdown operation is not just about preserving the equipment. It's also an opportunity to improve our professionalism and responsibility. Now, let's move on to the measurement process. As shown in the figure, if there is an existing part inspection program, you can load the program for measurement. If there is no program, the first step is to analyze the drawing and develop an inspection plan. Based on the inspection plan, select appropriate measuring equipment and fixtures. Configure the probe and probe system according to process requirements. Establish an accurate coordinate system and write a correct inspection program to ultimately generate a real and reliable inspection report. The image shows the part's measurement drawing. Based on the drawing, we need to determine the measurement elements to be inspected in the order of inspection. We also need to define the reference type for the part's measurement elements, such as design reference, process reference, inspection reference, etc. The reference elements are then used to establish the workpiece's coordinate system. For example, if the drawing indicates 12 dimensions that need to be evaluated, we follow the principle of first measuring the reference planes A, B, and C. Based on the principle of reference overlap, we use these 3 planes to establish the rectangular coordinate system. Next, let's move on to part clamping. The clamping position of the workpiece should be determined based on the measured characteristic elements. Suitable general or specialized fixtures should be used to ensure that all elements can be measured with a single clamping whenever possible. The clamping process needs to consider the following points. 1. Good clamping stability. 2. Reproducibility and high reliability of the clamping. 3. Easy clamping process, fulfilling the requirements for measuring features with different probe placements. In this lesson, we not only learned the basic operation specifications for the coordinate measuring machine, but also highlighted the responsibility that professional operators should bear. Every operation impacts the quality of the product and the reputation of the company. We are responsible for ensuring that each step is carried out meticulously and accurately. I hope that in your future studies and work, you will always maintain a sense of responsibility and professionalism, contributing to the development of enterprises and society. Finally, please reflect on today's lesson and complete the following exercises to consolidate the knowledge you've learned and deepen your understanding. This concludes our lesson. See you next time.